Hello everybody, Sir Beaton here and welcome back to another mathematics video. In this video we will be continuing our journey with functions and we will be looking at as you can see on the picture, the roots of a function. No, not these kind of roots. The roots that we're talking about will be the mathematical roots. So at the end of this video you should be able to graph quadratic functions and also identify the roots in the graph of the function. So what do we mean by the roots of a function? We know what a function is, but what do we mean by the root? So the root of a given function is that value which, when substituted into the equation in place of the unknown, which most times would be x, will make the equation true. And by make the equation true, we know for a quadratic, most times it's equal to 0. So when you put in a value for x, the value for x that makes that equation equal 0, that is what we call the roots of the equation. So the roots of the equation, you can find that by solving, or you can find that from looking at the graph, or you can find it by substituting numbers until you find the numbers that will give you 0. So that is what we mean by the roots of a function. So the roots of a quadratic function f of x is equal to ax squared plus bx plus c, which is the general form for a quadratic function, are the values of x when f of x, which can be replaced with y. So when f of x is equal to y, which is equal to 0. The values that when we substitute here for x, you will get 0. So that is what we mean by the roots. So let's look at how we can identify the roots on a graph. So the roots, most times we use the symbol alpha and beta, which would be, this is alpha and this is beta. The roots of a quadratic function are indicated in the figure below. So for the roots here, we see if we have the quadratic function, this is the quadratic function. So for the roots, it will be the part on the quadratic function that crosses the line y equals 0, which will be this line here. So the roots will be at this point and at this point. So that is where the function crosses the line y equals 0, or crosses the x-axis. So that is how we can identify the roots on a graph. The part at which the function cuts the x-axis, or cuts the line y equals 0. So since y is equal to 0, in this case, what that simply means, we replace y with 0, and when we solve for x, we will get the values of x that will make the function equal 0. So that is the correspondence between the graph, identifying the roots on the graph, and identifying the roots when you work it. So with that being said, now that we have an idea of how to identify the roots on a function and how to get the roots from an equation, let's look at an example of how to identify the roots. We'll graph the function and then we identify the roots from the graph. And sometimes we may discover the roots while we are attempting to get the points to graph the function. But for us, before we go into that, let's look at this here. It says the roots of the quadratic equation x squared plus 2x minus 3 equals 0 are negative 3 and 1. Because, so as I said, because when we substitute either negative 3 and 1, this equation will be true. So we can substitute negative 3 into this function. So instead of x squared, we will say x is equal to negative 3. So we'll say negative 3 squared plus 2 times x, instead of x, we say negative 3 minus 3 is equal to 0. So negative 3 squared would be negative 3 times negative 3, which will give you a positive 9, plus 2 times negative 3 would be negative 6, so minus 6. So the plus and the minus will cancel out and give us a minus. Then we have the minus 3, and that should be equal to 0. So 9 minus 6 is 3. 3 minus 3 is 0. So 0 is equal to 0. So because when we substitute negative 3 into the function, it shows that this equation is true, or that quadratic equation is true. So that means negative 3 is a root. So also we said that 1 is a root, so 1 should do the same thing like what negative 3 did. So we'll have x squared, instead of x squared, we'll have 1 squared plus 2 times, instead of x, we'll have 1 minus 3 is equal to 0. So 1 squared will be 1 plus 2 times 1 is 2. Minus 3 is equal to 0. So 1 plus 2 is 3. 3 minus 3 is 0 is equal to 0. So the roots of this quadratic equation are negative 3 and 1, because when we substitute those values, it will make the equation true. All right? So that is how we know two numbers are the roots of a quadratic equation. So let's look at this example. So this example says, draw the graph of the quadratic function f of x, which is equal to x squared plus 2x minus 8 for the domain x is greater than negative 5, x is greater than or equal to negative 5, and x is less than or equal to 3. So we're talking about this domain here, and we're talking about drawing this function. So the beauty about drawing any function or any line or any graphing anything, you can just substitute values into the function and that will give you coordinates, and then at the end you just connect the coordinates to get the function. And that is how we will tackle this question. We'll use the domain, we'll go from negative 5 all the way to 3, we'll substitute all of those values into this function, and that will give you a pair of coordinates that we will use to substitute and use to graph the function. So let's write down the coordinates that we'll use. So we'll go, so this coordinates would represent all the values for x. So we say x will be equal to, we'll start off from negative 5, and we'll go negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3. So we'll go all the way from negative 5 straight to 3. We'll substitute each one of those values individually into this function here, and we will get a pair of coordinates. So let's start off. So the function that we have would be f of x is equal to x squared plus 2x minus 8. So this is the function that we're using. All I did was replace this colon here with this here that we know how to write the function. So from previous videos, we know that f of x is the same as y. So you can just replace this f of x with y. So we'll say y is equal to x squared plus 2x minus 8. And now when we substitute these values for x, we'll get a corresponding y value, and that will be the pair of coordinates that we'll use to plot. So what we'll have y will be equal to, let's start off with the negative 5. So instead of x squared, we'll have negative 5 squared plus 2 times x, which is negative 5, minus 8. So y will be equal to, so negative 5 squared would be, negative 5 squared would be 25. Negative 5 times negative 5 is positive 25. 2 times negative 5 would be minus 10. And this is minus 8. So y will be equal to 25 minus 10 minus 8 would be equal to 7. So hence our coordinates would be x value, which is negative 5, and 7. So now we want to move on to the negative 4. So we'll have y is equal to, so instead of x squared, we'll have negative 4 squared plus 2 times, instead of x, we'll say negative 4 minus 8. So hence y will be equal to, so we can punch this in a calculator just like that. So negative 4 squared would be 16. So it'll be 16, 2 times negative 4 would be minus 8. So 16 minus 8 minus 8 would give us 0. So y is equal to 0. So hence our coordinates here would be negative 4 and 0. And then now we want to move on to negative 3. So we'll have y is equal to, instead of x squared, we'll have negative 3 squared plus 2 times x, which will be negative 3 minus 8. So we'll have y is equal to, so negative 3 squared would be 9. 2 times negative 3 would be minus 6 minus 8. So 9 minus 6 minus 8 would give us a value of y being equal to negative 5. So our coordinates here would be x, which is negative 3, negative 5. So let's use another color for the next one that we want to move on to. So let's use black. So we already finished with negative 3. Now let's move on to negative 2. So y will be equal to, instead of negative x squared, we'll have negative 2 squared plus 2 times, instead of 2 times x, we'll say 2 times negative 2 minus 8. So y will be equal to, so negative 2 squared would be 4. 2 times negative 2 would be negative 4 minus 8. Y will be equal to, 4 minus 4 would be 0. 0 minus 8 is negative 8. Hence our coordinates for here would be negative 2, negative 8. So the next term that we want to move on to would be the negative 1. So you'll have y is equal to, so instead of x squared, we'll have negative 1 squared plus 2 times negative 1 minus 8. So y will be equal to 1, negative 1 squared would be 1 plus 2 times negative 1 would be, so this will actually be a minus, 2 times negative 1 would be a minus 2, and then a minus 8. So we'll have 1 minus 2, which would be negative 1, minus 8, which would be y is equal to a minus 9. So hence our coordinates here would be x, which is negative 1 and negative 9. So let me use another color. Let's use a blue to move on to the next one. So the next number that we'll use is 0. So y will be equal to, instead of x squared, we'll have 0 squared plus 2 times x, which is 0, minus 8. So y will be equal to 0 times 0 is 0, 2 times 0 is 0, 0 minus 8 would be a minus 8. So our coordinates here would be 0, negative 8. Now let's move on to positive 1. So we'll have y is equal to, instead of x squared, we'll have 1 squared plus 2 times x, which is 1, minus 8. So y will be equal to 1 times 1 is 1, plus 2 times 1 is 2, minus 8. So y will be equal to 1 plus 2 is 3. 3 minus 8 would be 3 minus 8 is a negative 5. So you'll have y is equal to negative 5. So our coordinates here would be 1, negative 5. Let's move on to another number to substitute, another value for x. So we finished with 1. Now let's move on to 2. So y will be equal to, instead of x squared, we will have 2 squared plus 2 multiplied by 2 minus 8. So y will be equal to 2 2 is 4 plus 2 times 2 is 4 minus 8. So y is equal to 4 plus 4 is 8. 8 minus 8 is 0. So coordinates here would be 2, 0. Then the last one, which would be 3. So we substitute 3 into this function. So we'll have y is equal to, instead of x squared, we'll have 3 squared plus 2 times 3 minus 8. So y will be equal to 3 3 is 9. 2 times 3 plus 2 times 3, which would be 6 minus 8. And y is equal to 9 plus 6 minus 8 would be 7. Our coordinates here would be 3 and 7. Now we have all of our coordinates from the domain that they gave us. Now we use these coordinates to plot our graph. So an important thing to decide when we are plotting our graph is to decide the scale that we'll use. So in order to cater for all of the x coordinates that we found, and we saw x range from negative 5 all the way to 3, we will say let 1 cm, so we know 1 cm on the x-axis would be like from here to here. So let 1 cm represent 1 unit on the x-axis. So from here to here it would be 1, 2, 3, and then here it would be 4. It would be negative 1, negative 2, negative 3, negative 4, negative 5, and negative 6. And then for the y-axis, to cater for all of the y coordinates, we see y goes from negative 9 all the way to positive 7. So we will let 1 cm represent 5 units on the y-axis. So from here to here would be 5 units. So we'll go 5, and then here would be 10, 15, 20. From here to here would be negative 5, negative 10, and negative 15. So now let's use our coordinates to plot on this graph. So we see we started off with the first point, which is negative 5 and 7. So we go across to negative 5, and we go all the way to 7. So we see here is 5, so 5, 6, 7. So there would be 7. So next point we want to plot would be negative 4, 0. So we go across negative 4 and we go up 0. So that would be right here. So we plot that point there now. And then the next point would be negative 3, negative 5. So we go across negative 3 and we go down negative 5, which would be like right here. And then next point would be negative 1, negative 9. So we go across -1 and we go down -9. So if here's 10, -9 will be 1 above that, which will be like right here. And then we go 0, -8. So we go 0 across, so we know 0 is right here. So we go -8, which would be, since here is -10, 8 would be somewhere right here. And then we move on to the next one, which is 1, -5. So we go 1 across and -5, which would be like right here. And then we go 2, 0. So we go 2 across, 0 up, so that will be right here. And then we go 3 across, 7 up. So we go 3 across and 7 up, which would be like right. Since here is 3, so 7 would be, since here is 5, 7 would be 2 above that. So there would be that coordinate. And now we have all of our points to draw this graph. So we connect now. This is where we connect the points to get the graph. So we connect there, we go through there, we go all the way there, and we go all the way here, and we go all the way here, and we go all the way here, and we go all the way here. And this is what our curve will look like. And we were able to draw this curve by simply substituting some values into the function to get some points, and then we just use those points to draw the curve. And this is very easy. You can do this for any curve that you want. You just substitute some values and you will get the coordinates, and you just connect the coordinates. So they also ask us to state the roots of the quadratic function. So from looking at this here, we already saw that the roots would be where we found y to be equal to 0. So we saw y was equal to 0 at -4 and 2. So we can also see from the curve or from the function that the roots here would be the point at which the line crosses the x-axis. So it should be right here and right here. So the roots here, the roots of this quadratic function would be -4 and 2. And that is how we can get the roots. And that is how we draw a quadratic function. Once again, if they give you a domain, you use that domain and you substitute those values for x into the function, and then you will get coordinates. Then you use those coordinates to plot on the Cartesian plane, and then you just connect the points, and that will give you the function. And then from the function, you can be able to identify the roots. Or you can even look at, if you substitute one of the values, whichever one gives you 0 as the value of y, we know that will be the root. But we know we can also identify the root from the curve. So with that, I will leave you here. I trust that you now have an understanding of how to draw a quadratic function, not sketch, how to draw a quadratic function. And you are able to identify the roots from a quadratic function. Remember, the roots would be the part of the curve or part of the function that crosses the x-axis, or the part of the curve in which y is equal to 0. Of course, I must leave 2 for you to practice on your own. So I have here 2 questions, number 1 and number 2. So draw these quadratic functions and then identify the roots in the function. So you have 2 for you to practice here. And with that, I'll stop here and I will see you in the next video. Take care.